Hi, this is Chris Armstrong from Regal Technologies, back with Patrick Andre from Andre Consulting.
Hello.
Hi, Patrick. Today, Patrick, I want to talk a little bit about radiated emissions.
Okay.
So we have a little proto board set up here that we've worked with, a little near-field probe set on it. And we're actually going to highlight a little activity here, really just on the FPGA that sort of runs this board.
Right.
So here in sweat mode, we're looking at a 2 gigahertz span. And what we can see here really are some clock harmonics.
Mm-hmm.
So the main one is at this 125 megahertz point. So that's really the main clock. There are a number of other subsidiaries over here. One of them I want to look at today is the 875, so the 7th harmonic of that signal.
Right.
So now that we've identified it, we can go ahead and switch over to real-time mode. So now what we'll see here in a second is a real-time capture. So that is a gapless capture right around, of the 40 megahertz, right around that 875 megahertz clock.
Looks very good.
Yeah, we can see a lot of noise here.
Mm-hmm.
But I think we can dig in further and see some more activity that might be of interest.
Okay.
So one way we're going to do that is to switch over to the density spectrogram. And now what I think is really interesting is we see here is on this board we see some of these frequency changes, these slow arcs that are happening over time.
On either side of the fundamental, you mean?
Yeah, and then they reset like that, and it'll start up here in another second. Really, in the noise, even on the real-time display, you can't see any of that activity, but it becomes clear down here in the spectrogram.
Yeah, here it comes through. Yeah, I'm not seeing that in the real-time mode, and I would never have seen it in the normal swept mode.
Yeah, so we were hypothesizing what we think this might be. And it may be some sort of motion or dithering on the 125 megahertz clock that now has been expanded to a wider span on the 7th harmonic.
That can be very valuable.
Interesting debugging techniques for radiated emissions with near-field probes and real-time spectrum analysis. Thanks, Patrick.
You're welcome.